Welcome to this virtual lecture on head and neck anatomy. We've been doing a series on anatomy of the head and neck from a topographical approach. And in this particular session, we are going to look at anatomy of the ear. Actually, anatomy of the ear is quite extensive. And so I've chosen to split the anatomy of the ear lecture into two. The first part will focus on the temporal bone anatomy. The second part will look at the auditory and vestibular apparatus and the mechanisms of those sensations. In this particular lecture on anatomy of the temporal bone, we are going to look at the following. I'll give you some general concepts about the ear anatomy and the general functions of those parts of the ear. We'll also then talk about the morphological parts of the temporal bone itself. That will take us some time. We'll be looking at the key features of each of the morphological parts. Importantly, also, we are going to look at the various spaces or cavities which are present within the temporal bone, which are related to the ear. The ear as a function of hearing and equilibrium. Lastly, we'll take some time also to just look at how the ear looks like, how the temporal bone looks like from a CT scan point of view, and we'll just look at an axial CT scan of the temporal bone. Let's start with the first agenda there, some introductory concept about the ear and temporal bone. We know that the ear is subdivided into three basic parts: the external ear, also known as the outer ear, the middle ear, and the inner ear. So this is the outer ear, this is the middle ear, this is the inner ear. The outer ear consists of this thing, which we call the pinna of the ear, and this one, which we call the external auditory canal. The main function of the outer ear is to collect sound waves, which then are taken to the eardrum, also known as tympanic membrane. The role of the tympanic membrane is to convert the sound waves into vibration energy. And the vibrations are then passed through the middle ear. So this is the middle ear, also known as the tympanic cavity. The middle ear houses ear ossicles. The ossicular chain consists of three bones: malleus, stapes, and incus. Now, the ear ossicles primarily amplify the vibrations which come from the eardrum. And through that amplification, the vibrations are then sent into the inner ear. The inner ear is the one that houses the receptors, organs for hearing, and the receptor organs for equilibrium. So that's the general anatomy of the ear. That particular inner ear is the one that will receive the 7th and the 8th cranial nerves there. But of course, the 8th cranial nerve is the one that supplies the ear. So the 7th cranial nerve just passes around it. Most of the components of the ear are largely, not necessarily entirely, but largely contained within the temporal bone. Of course, as you can see here, the pinna is not within the temporal bone, and some part of the external auditory canal is also not part of the temporal bone, but the rest of the ear are largely within the temporal bone. It is for that reason, therefore, that we need to understand the topographic anatomy of the temporal bone. And so that brings us to our next agenda, to learn the morphological parts of the temporal bone. Among all the bones of the skull, I find the temporal bone perhaps the most complex of them all. Despite that complexity, I'll try to make it simpler for you so that you understand the anatomy of the ear. We know that the temporal bone is part of the bones of the neurocranium. Some part of it are in the skull base, some part of it will cover the calvaria actually. It's a paired bone, so we have a right and a left part. As we can see, they extend from peripherally all the way toward the center, not quite meeting right and left, but they approximate the center. They are the skull base. Each temporal bone can be viewed to have a number of parts. Let's talk about the parts. So there's a squamous part of the temporal bone, which is this part here. We have the zygomatic process of the temporal bone. Morphologically, the squamous part and the zygomatic process are one, because there's no suture separating the squamous part from the zygomatic. So morphologically, the two are actually one. I like discussing them separately because they look different. The tympanic part is this bone here around the external auditory meatus. The lateral process is this projection downward there. We have the mastoid process, or the mastoid part, so to speak, which is this region here. The mastoid process is the projection from the mastoid part. And lastly, we have the petrous part. It's hard to see the petrous part from this view, but from another view, you can be able to see the petrous part. So this is the petrous part, and this is the mastoid part. Again, you notice that the petrous and the mastoid are actually morphologically one entity as well. So because of that, some people may talk of temporal bone as having just 4 parts: squamous, tympanic, styloid, and petromastoid segment or portion. So the zygomatic is merged within the squamous, and the mastoid and petrous are merged as one morphological entity, which is true. However, we'll discuss them in this manner and perhaps in that order for the sake of clarity. Let's start with the squamous part, which is this part here. The squamous part of the temporal bone lies anteriorly and superiorly. So it's the anterior-superior part of the bone. It is very large, as you can see, and flattened like a plate. When you look at it, it forms the lateral boundary of the middle cranial fossa, which means that the parts of the brain which are in the middle cranial fossa will be lying medial to the squamous part of the temporal bone. From the external surface, the things we can see are the following. That in this region labeled 1, it formed the temporal fossa, or part of the temporal fossa. This is where the muscle temporalis actually lies. Slightly posterior, inferior there, around the region labeled 5, is a triangular region we call the suprameatal triangle. The boundaries of the triangle are outlined in that other image up there. So the suprameatal triangle is an important region clinically because it's the surface landmark for the mastoid antrum. Mastoid antrum is a few millimeters deep to that region labeled 5. The squamous part of the temporal bone also has this depression here, labeled 8, which receives the condylar process of the mandible to form the temporomandibular joint. So this is called the mandibular fossa or the glenoid fossa for temporomandibular joint articulation. This image shows you better the mandibular fossa, which is also known as the glenoid fossa, that one, for TMJ articulation, temporomandibular. So this is the condylar process of the mandible, and this is the glenoid fossa. Now that was from the external. How about from inside? From inside, what we see is that it is concave, deeply concave, so to speak. and houses the temporal lobe of the brain. So the temporal lobe of the brain usually rests here. Important to note is that the inside is grooved by the middle meningeal artery. This is the middle meningeal artery that grooves the inside of the squamous part. Middle meningeal artery is a branch of the maxillary artery that goes intracranially to supply the meninges within the brain, and in particular entering through the middle cranial fossa. And perhaps that qualifies why it's called the way it's called. Now we can talk about the zygomatic process, which I've told you is morphologically part of the squamous part. Zygomatic process is an anterior-inferior projection from the squamous part, and there's no sutural line. The projection from the squamous part arises by two routes. There's a posterior route, which is this one here. This is a posterior route of the zygomatic process. This posterior route of the zygomatic process has some projections. So if you follow that one, we see the suprameatal crest, labeled 2 there. But if you follow this one, we see that tubercle behind the glenoid fossa. We call the postglenoid tubercle. So the postglenoid tubercle and the suprameatal crest constitute the posterior route of the zygomatic process, labeled 10. We have an anterior route which lies around the region labeled 9. We call this one the articular eminence. And the region labeled 8 itself, the fossa, also constitute part of the anterior route of the zygomatic process. You perhaps may not see that nicely from that view, but this one shows you better. So this is the zygomatic process, the inferior view of it. This is the articular eminence. This articular eminence is the one that prevents anterior dislocation of the head, of the condylar process at the TMJ. And this is the glenoid fossa, the point where the condylar process of the mandible rests. And this is the postglenoid tubercle, which is part of the posterior process, or the posterior route of the zygomatic process. The zygomatic process articulates with the temporal process of the zygomatic bone. So we have the zygomatic process of the temporal bone, and we have the temporal process of the zygomatic bone. Sounds like a tongue twister, but this is it. So this is temporal bone, and this process, it gives towards the zygoma. So we call zygomatic process of the temporal bone. This is zygoma. This process, it gives towards the temporal bone. So we call the temporal process of the zygomatic bone. So the two processes join at the zygomatico-temporal fissure, which is that one. And the two complete an arc, which we call the zygomatic arc. Medial to this arc is this space here. So this is the temporal fossa, and below that one is what we call the infratemporal fossa. This image shows you that anatomy better. So this finger is within the temporal fossa here, and the tip of the finger there, infratemporal fossa. We'll have a lecture one day on the boundaries and content of those two fossa. Let's look at the third entity of the temporal bone, that's the tympanic part. The tympanic part of the temporal bone is actually a curved bone, highly irregular, but curved. It lies both anterior as well as inferior to the external auditory meatus. As you can see, this is the external auditory meatus, this is posterior, this is anterior. So this is the tympanic bone. It actually forms most of the margins of the osseous part of the external auditory meatus or external auditory canal. We'll talk more about that when you look at the spaces and cavities within the temporal bone. It also forms the posterior wall of the glenoid fossa, as you can see, together with the post-glenoid tubercle. So it also constitutes part of the posterior wall of the glenoid cavity. The parotid gland sometimes also rests actually on that particular bone there, form part of the bones that are in the base of the parotid gland. This image shows you the tympanic bone here, which is forming part of the posterior wall of the glenoid fossa, as you can see. Remember, this is the post-glenoid tubercle, but now this is the tympanic bone. There's a fissure that separates the petrous bone from the tympanic bone. So this is the petroso-tympanic fissure. There's some structures which pass through there. This is the petrous bone. This is squamous, remember? So this is the petroso-tympanic fissure. The inferior border of the tympanic bone is a bit sharp and forms a sheath around the styloid process. That sheath is what we call the vaginal process, the one labeled 18 there. The sharp projection and partly forms the sheath around the styloid process. So this is what we call the vaginal process of the tympanic bone. The stylomastoid foramen will be somewhere here between the mastoid process and the styloid process, so somewhere around there. Of course, inferiorly. The fourth entity is the styloid process. So the styloid process is a slender projection, highly variable. It can be very massive, like this and appear massive. Some of them are short, so it's the length is highly variable. But a sharp projection inferiorly and slightly anterior. The proximal part is sheathed, as I've just mentioned, by a part of the tympanic bone. This one here, the vaginal process of the tympanic bone. Then this is the styloid process. There are a number of muscles that attach towards the tip of the styloid process. Those muscles, together with the ligaments, constitute what we usually call the styloid apparatus. We can mention the muscles. So there's one that, so this is the styloid process. This is the mandible, so this is anterior. So this one comes from the styloid process to the tongue. We call it styloglossus muscle. This one comes from the styloid process to the hyoid bone, so we call it stylohyoid muscle. This one comes from the styloid process to the pharynx, so we call it stylopharyngeus muscle. Stylopharyngeus in particular is unique because it has a different embryonic origin compared to the others. Anyway, all of them constitute the styloid apparatus. The ligaments are not shown here. Important to note is that the styloid process is very close to a number of structures. We've just mentioned about parotid gland. It's on the bed of the parotid gland, part of the parotid bed actually. Facial nerve also passes very close to the styloid process. The external carotid artery also passes very close to it. And the internal jugular vein, which you can actually see here, also passing very close to the styloid process. So it's a landmark for a number of things. All right, now we can talk about the mastoid process a bit in detail. As I've already mentioned to you, the mastoid and the petrous part are morphologically one, constituting what we call the petromastoid portion of the temporal bone. However, for the sake of description, I prefer discussing them as separate entities. This is the mastoid process. Sorry, this is the mastoid bone. And that inferior projection is the mastoid process. But the whole of this is the mastoid part. It's quite massive, as you can see. The external surface of the mastoid part projects downward as the mastoid process. This external surface is highly roughened. It's rough, so to speak. This roughening is because of a number of muscles which attach onto the mastoid process, but also because of some blood vessels that also groove the mastoid process or the mastoid itself. For example, you can see groove labeled 15 there, another one labeled 16 there. Those are actually groove for vessel 16, groove for muscle 15. Importantly, we can mention the muscles that attach onto the mastoid that make the outside to be really rough. So we have the digastric muscle much medially there. Then we have the attachment for the longissimus capitis there. We have attachment for the splenius capitis there. Those ones tend to be a bit medial. Then on the lateral aspect, we have the attachment of the sternocleidomastoid, which you can see there. The ones which are not shown here are attachment of occipitalis, which we'll expect to be a bit higher, and attachment of the auricularis posterior as well. So those muscles make the outside of the mastoid to be a bit rough. On the internal surface, this is foramen magnum. This is the groove formed by the sigmoid sinus as it moves toward the jugular foramen. Remember, this is inside. So this is actually still part of the mastoid part. So what we note is that the middle aspect of the mastoid part is grooved by the sigmoid sinus. Maybe this image captures that better. This is middle aspect of the temporal bone, with that being the squamous part. This is the petrous part. This is the mastoid part. So this is the groove of the sigmoid sinus. You can see there's a foramen there, which is known as the mastoid foramen for passage of mastoid emissary vein connecting to the sigmoid sinus. The inside of the mastoid portion is worth talking about. The inside is predominantly trabeculated, as we can see. These trabeculae are variably pneumatized. Now, you know, you can have trabecular bone, but the inside is occupied by bone marrow. But you can also have trabecular bone, but the inside is occupied by air. So when it's occupied by air, then we call that pneumatization. The inside of the mastoid bone is variably pneumatized. And there are some three entities of pneumatization I want to talk about. The first one, which we call the mastoid antrum. This is mastoid antrum. It's a large cavity on the upper part of the mastoid bone, usually measuring about 1 centimeter in diameter. This cavity lies posterior to the middle ear cavity. That cavity is almost constant, almost always there. Now, something that connects the mastoid antrum to the middle ear cavity is a narrow channel, this region here, which we now call the adductus ad antrum. It's just a narrow channel that connects the middle ear cavity, the tympanic cavity, with the mastoid antrum, adductus ad antrum. If the mastoid antrum is constant, then the adductus is also constant. But we have what we call the mastoid air cells. The mastoid air cells actually if we are at the level of the mastoid antrum, the floor of the mastoid antrum has communications with the mastoid air cells. So mastoid air cells communicate with the mastoid antrum. The floor of the mastoid antrum has communications with the air cells. The mastoid air cells are variable. They are interconnected pockets of air, variable number. So they could be many, they could be few. They also vary in their form. They could have very funny kinds of shapes. And they also vary in their size. They could be large, they could be tiny. They also vary in terms of how far they extend. Sometimes they extend even beyond the mastoid bone itself. So those are the mastoid air cells, and you can see them here. Now, these are CT images showing us at the base of the skull. The intention is to show us again the mastoid air cells. So look at this degree of pneumatization of mastoid here. It's quite extensive and most likely going even beyond mastoid to even involve the petrous, as we can see there. So, and you can see sometimes the right and the left are also variably pneumatized. You can see the pneumatization level here is quite extensive compared to this other size. So remember, internally we have the mastoid antrum, adductus ad antrum, and mastoid air cells. The first two are constant, the last one variable. Most of the time, however, in adults, the mastoid part will actually have mastoid air cells. This one also still shows us the mastoid, and it's a video I'm going to play. Follow this. So this is the mastoid. It's a cut from below. I can see the degree of pneumatization of the mastoid bone. So that has shown us the degree of pneumatization of the mastoid bone. Let me take it somewhere so that you also appreciate the addutus ad antrum and the antrum itself. So this is still mastoid air cells. Then at that level, we are starting to see the mastoid antrum and the addutus ad antrum. Even here, so this is the mastoid antrum, and that is the addutus ad antrum, connecting to the middle ear cavity. Okay, so that is mastoid portion. Now we can talk about petrous portion, which is largely the subject matter. The petrous portion of the temporal bone is predominantly compact, very heavy bone. It's a wedge-shaped bone interposed between the sphenoid anteriorly and the occipital bone posteriorly, and it rests at the base of the skull. This petrous bone is the one that houses the different channels within the bone that house the ear. In terms of its orientation, it is inclined slightly superiorly and anteromedially. So from outside going in, you'll go anteriorly, medial, and slightly superior. It's pyramidal in shape, with the apex being around here, and so the base being lateral or posterolateral, so to speak. Posterior lateral and slightly inferior. Because of it being pyramidal with a somewhat triangular base, it will have 3 borders. This is the superior border, which is the longest border. We call that superior border the petrous ridge. This petrous ridge is usually for the attachment of a dural reflection that separates the cerebrum from the cerebellum. We call it tentorium cerebelli. And on that dural reflection, there's usually a sinus running there. We call that superior petrosal sinus. it runs on that superior border. This is the anterior border, it's slightly shorter. And as you can see, it's interrupted by some groove there for a nerve that I'm going to talk about shortly. And this is the inferior border, slightly irregular and also very short. The inferior border forms a margin where the inferior petrosal sinus runs from the cavernous sinus somewhere here to the jugular foramen, which is that point. This is the groove of the sigmoid sinus, which was grooving the medial aspect of the mastoid part. So this is the apex. The base is this region here, best viewed from externally. And there are three surfaces. We have the posterior surface here. The posterior surface forms the anterior wall of the posterior cranial fossa. But it also contains this one, the opening of the internal auditory canal inside. We call that the porus acousticus interna. It's just the opening of the internal auditory meatus. The internal opening of the internal auditory meatus is known as porus acousticus. You can call it porus acousticus internus. The anterior surface, which is this one, is characterized by some big swelling here, this one, marking the location of the ear actually. Also, some thin plate of bone somewhere here known as tegment tympani, which forms the roof of the middle ear. Tegment tympani. And we have this groove for the greater petrosal nerve, a nerve that is branching from the facial nerve to come and join with the deep petrosal nerve to form the nerve of the pterygoid canal. This image captures for you the tegment tympani, this thin bone here that is on the roof of the middle ear, but also the arcuate eminence, which is somewhere there, marking the location of the structures within the ear, some canals and the like. The inferior surface of the petrous bone is highly irregular and has the impression for the jugular vein, internal jugular vein. We call that the jugular fossa. And the opening for the internal carotid artery, that is the entry into the carotid canal. So those are inferior within the petrous bone. That means that the carotid canal is actually a canal inside the petrous bone. Okay, we've now talked about the morphological parts of the temporal bone. And in particular, you've taken note of the parts of the petrous bone, because now what we're going to talk about next largely involve the petrous bone, in as much as the other parts will go, also going to be affected. So this next session will be focusing on the spaces or cavities that are found within the temporal bone that are related to the ear anatomy. Conventionally, when we discuss anatomy of the ear, we usually want to start from the outer ear, middle ear, and inner ear, and there's nothing wrong with that one. Actually, in our next lecture on the ear, where we're going to talk about the apparatus for hearing, I'll take that approach. However, for this one, I want to take the reverse approach, so that your mind meets somewhere and this thing should make sense. I just want to have a different approach to it, because the anatomy of the ear is found to be very complex, especially what we want to talk about. And so I'm just trying to do a different approach to it, and perhaps this will help in enhancing our understanding. and look at the spaces from inside out. That means I'll start from the most inner side coming out. We'll not start with the inner ear. There is something much inner than the inner ear, and that's the internal auditory canal. So this is the opening for the internal auditory canal. It's also known as the internal acoustic meatus or the internal acoustic canal. Some people prefer to use the term meatus for the opening and the whole channel for the canal. So this internal auditory meatus or internal auditory canal is a bony canal within the petus portion of the temporal bone. The aim of this canal is to transmit neurovascular structures from the cranial cavity to the ear. So that's the primary role of the internal auditory canal. Now, the medial aspect of the canal, which is this point here, is what we call the porus acousticus internus. It's the medial opening of the canal. So what enters through the porus acousticus internus? The contents of the canal. We have a labyrinthine artery, which is usually a branch of the basilar artery. You have the facial nerve proper, which carries motor fibers of facial nerve, seventh cranial nerve. You have the nervus intermedius, which carries the parasympathetic and sensory components of the facial nerve. We have the vestibulocochlear nerve, which is the eighth cranial nerve, having both vestibular and cochlear nerve. And we have the vestibular ganglion along the path towards the end of the nerve, also located within the canal. So this image captures for you those neural structures that we mentioned: the cochlear nerve, the facial nerve, proper nervus intermedius there, the vestibular nerve. So the cochlear nerve and the vestibular nerve constitute the vestibulocochlear nerve. You can see the ganglion there. After the ganglion, usually the vestibular nerve splits into two. So you have the superior and the inferior vestibular nerve. The neural elements within the internal auditory canal occupy specific zones of the canal, and especially towards the end of the canal, as you can see here. So anterosuperiorly, we have the facial nerve. Anteroinferiorly, we have the cochlear nerve there. Posterior-superiorly, we have the superior vestibular nerve, and posterior-inferiorly, we have the inferior vestibular nerve. Maybe this image captures for you that better. So this is anterosuperior. This is posterior-superior, posterior-inferior, and anterior-inferior. So this is cochlear, facial nerve and proper nervus intermedius, superior vestibular and inferior vestibular. There's usually a transverse ridge that separates the upper from the lower components, and there's something called the Bill's bar that tries to separate the anterior from the posterior superior segments or quarters. The lateral end of this canal of the internal auditory meatus is termed the fundus. And from the fundus, there'll be openings for the different nerves exiting. So this is the Bill's bar, separating the anterior superior from posterior superior region. Remember, posterior superior here is for the vestibular nerve, superior vestibular nerve, posterior inferior for the inferior vestibular nerve, and anterior inferior for the cochlear nerve. So this is the transverse crest, or the falciform crest, so to speak, and this is the Bill's bar. This region is what you call the fundus of the internal auditory canal. It's the lateral end of the canal. The next space we want us to talk about is now the inner ear. You see, the aim of the internal auditory canal is to transmit those structures to the ear. Vestibulocochlear nerve primarily goes into the inner ear. I'd mentioned to you that the inner ear is the one that contains the receptors for hearing as well as the receptors for balance. It consists of what we call the bony labyrinth, also termed the otic capsule. The bony labyrinth is a series of interconnected or interlinked cavities present within the petrous portion of the temporal bone. The system of interlinked cavities called the bony labyrinth. This bony labyrinth is lined by the periosteum of the skull, basically. So the cavities are lined by periosteum. And deep to that periosteum, or internal to that periosteum, is some fluid. The fluid that is within the bony labyrinth is called the perilymphatic fluid, or perilymph. This fluid has similar concentration, or almost similar concentration, that one of the extracellular fluid, and even like CSF. Within the bony labyrinth is a system of membranous sacs and ducts that take the contour of the bony labyrinth. So remember now, these are membranous. They are epithelial-lined membranes, but they follow the contour of the bony labyrinth. They are found within the bony labyrinth. They're also interconnected. So this membranous labyrinth will be as extensive as the bony labyrinth. They are limited by the bony labyrinth. The membranous labyrinth itself contains a unique fluid within it, and that's the endolymphatic fluid. The endolymphatic fluid has similar concentration like the cytosol, the intercellular fluid. So what do you notice? If the membranous labyrinth is inside the bony labyrinth, and the membranous labyrinth contains endolymph, it means that perilymph is therefore between the wall of the membranous labyrinth and the wall of the bony labyrinth. Perilymph is between the two. So that is the general anatomy of the inner ear. We'll talk more about this general anatomy and especially the components of the bone of the membranous labyrinth in the second part of this lecture, where we're now going to look at the organ of hearing itself. We'll talk more detail about that, the different components of the membranous labyrinth. However, for this session, I want us to focus primarily on the bony labyrinth. The bony labyrinth is very dense and very hard bone. Usually the bone around this region is very hard compared to the rest of the petrous bone. Quite hard, very compact. The bony labyrinth contains 3 types of cavities. Remember, bony labyrinth are a system of cavities, but there are 3 types of cavities within this bony labyrinth, or what we call the otic capsule. This is what we call the vestibule, the semicircular canals, and the cochlea. Let's start with the vestibule. So this is the vestibule. It is the central part of the bony labyrinth, and it lies medial to the middle ear. So if this is the middle ear, it's just medial to the middle ear. That's the vestibule. It is perhaps the largest part as well of the bony labyrinth. It has some openings. There's an opening for the oval window. The oval window is where one of the ossicular chain bones, the steps in particular, attaches. So the foot process of the foot plate of steps attaches onto the oval window, transmitting vibrations from the middle ear into the inner ear. So that oval window is a lateral opening within the vestibule. Then we have openings of the semicircular canals. These are the semicircular canals. So they have openings which are posterior to the vestibule, on the posterior aspect of the vestibule. And lastly, we have the vestibular duct, not shown in this particular image, but somewhat an inferior projection from the vestibule. Usually the vestibule contains some components of the membranous labyrinth. In particular, the large ones, we have what we call the circle, and we have what we call the utricle. And we'll talk more about those ones in the next lecture. Now we can talk about the semicircular canals. Semicircular canals are 3 in number, and they're located posterior-superior to the vestibule. If this is the vestibule, the semicircular canals are posterior and superior to the vestibule. There are 3. We have the anterior semicircular canal. The anterior semicircular canal is sometimes called the superior semicircular canal. It has a vertical orientation. This is the anterior semicircular canal, which is also called the superior semicircular canal. It has a vertical orientation. Then there's a posterior semicircular canal, which is that one. Posterior semicircular canal is also having a vertical orientation. However, it projects more backwards compared to the anterior one, which projects more superiorly. As you can see, 1 foot of the anterior semicircular canal attaches directly to the vestibule, but the other one has a common stem with the posterior semicircular canal. Similarly, even the posterior semicircular canal, there's 1 common stem with that one of the anterior canal, but the other one attaches directly onto the vestibule. Usually the points of attachment of the semicircular canals tend to be a bit swollen, enlarged, and we use the term ampulla to refer to that. Then you have the lateral semicircular canal. The lateral semicircular canal is horizontal, and it projects laterally towards the middle ear. So it gives an impression on the middle ear there. Now, generally, when you compare the right and the left lateral semicircular canals, they lie within the same or near the same horizontal plane, or we can say that they are axial. They are horizontal. And so they are able to pick some rotational movements of the head. That's a bit different from the anterior and the posterior semicircular canals. The orientation of the superior or anterior semicircular canal is almost perpendicular to the long axis of the petrous bone. And then the orientation of the posterior semicircular canal is almost parallel to the long axis of the petrous bone. Now, what are the implications? The superior semicircular canal of one side is therefore parallel to the posterior semicircular canal of the opposite side. So if you compare the anterior semicircular canal of one side, it will be almost parallel to the posterior semicircular canal of the opposite side. But for the lateral semicircular canals, the right and the left one are parallel. Okay, I hope you've captured that concept quite well. If I was to say that in different words, if you compare the anterior semicircular canal of one side and the opposite side, they'll be at almost 90 degrees. Similarly, the right and the left posterior semicircular canals, their planes will be almost at 90 degrees to one another. But the lateral ones are almost parallel. Now we can talk about the third entity of the otic capsule, what we call the cochlea. Right, so let's talk about the cochlea itself. The cochlea is the most anterior part of the bony labyrinth. It actually lies in front of the vestibule. Now, as you can see here, the cochlea is highly folded. It makes several turns on itself, about 2 3/4 turn it makes on itself. The base of the cochlea faces the region of the internal acoustic meatus, but the tip or the apex of the cochlea, now that means faces away from that part. It has a conical central bone, which we call the modulus, and a spiral canal around that modulus. So remember that the canal is spiraling around the central bone. And this canal is wider from the base and it narrows towards the apex. Remember the number of turns is 2 3/4 turn. That makes us give names to the different turns of the cochlea. So we have what we call the basal turn, which is the widest and the largest. Then the intermediate turn and the apical turn. The apical turn, remember, is the one that is incomplete. So this image shows you, if you have to take a cross section through the cochlea, this is what you'll see. We'll see the basal turn, which is this one. Then the middle turn or the intermediate turn, which is that one, and the apical turn, which is that one. The cochlea has opening for the round window from which vibrations can be dampened from the inner ear. Now that round window there opens into the middle ear cavity. Okay, so we've looked at the 3 components of the bony labyrinth, the 3 components of the otic capsule. I want us to look at this image here to try to still make sense out of what you said. So this is an axial CT image located at the level of the middle ear to capture a few structures here. So from here, this is the posterior cranial fossa. So this is the internal auditory canal with the porus acousticus internus here and moving towards the fundus. So this is the internal auditory canal. It gives us this thing here anteriorly, and so this is the cochlea itself. This other one, which is behind the cochlea, is the vestibule. And remember that the semicircular canals will be posterior superior to the vestibule. So in this axial cut, horizontal cut, you may not see most of the components of it except this other one here, which is the lateral semicircular canal there. This is part of the middle ear. We are going to talk about it shortly. The second image is a video I'll play for you slowly so that you try to appreciate the structure of the inner ear. The image has been sliced from above. So at this point, you can see that bony element there. This is most likely part of the arcuate eminence of the petrous bone. And this is mastoid air cells. Let's play it slowly. So we're cutting, going down. There's the arcuate eminence. So we're still cutting, slicing down. We can now see the turn of the superior semicircular canal. You can see that orientation there. You can see the orientation I was telling you it's almost perpendicular to the long axis of the petrous bone. Okay, we are going on downwards. So this is the anterior limb of the superior semicircular canal, and that's the posterior limb of the same. Moving down, we can see groove for the superior petrosal sinus, usually on the petrous ridge. Let's continue going down. So this is the otic capsule, basically very thick bone, dense bone around the meatus, around the labyrinth. I'll take that back a bit so that you see something. Okay, now we can see this is the lateral semicircular canal there. You can also see the internal auditory meatus entering. And this is the route for the facial nerve. So remember, from the meatal part of the facial nerve, it goes into the labyrinthine part of the facial nerve. And then at that point, that's where the facial nerve turns. And so this is the genu. The first genu of the facial nerve is the location of the geniculate ganglion. This is showing you components within the middle ear. We had mentioned about the mastoid air cells. And then we have the mastoid antrum there. And that mastoid antrum is connected to the middle ear cavity through the adductus adantrum, which you can see there. Let's continue slicing downwards. I think you've seen the component of the facial nerve that I've just told you. From the genu of the facial nerve, we now have the tympanic part of the facial nerve passing through the medial wall of the tympanic cavity or the lateral wall of the inner ear. All right, we're going down. It's still playing downwards, so that's the vestibule. You can see that one, that's a vestibule. Going down, we can now see the lateral semicircular canal nicely, and the vestibule, the ampulla of the posterior semicircular canals, they are attaching to the vestibule as well. Remember, ampulla is the dilated part, so that is still vestibule. You can be ignoring the components of the middle ear cavity because we'll be discussing them, but put your attention now to the cochlea. The apical turn of the cochlea is there, and the intermediate turn of the cochlea is there. You can see that the internal auditory meatus enters into the cochlea there. The base of the cochlea is at the internal auditory meatus. That's the porus acousticus internus, and you can see how the internal auditory canal actually tapers towards the lateral side. That's the modulus, the central core of bone that forms the frame of the canals of the cochlea. So remember, we've not yet seen the basal turn of the cochlea. You will see it shortly. We are still cutting, going down. You can see posterior semicircular canal. Now look at the orientation of the posterior semicircular canal, almost parallel to the long axis of the petrous bone. And that's what I was saying you that this one and this one will make 90 degrees relationship. This posterior semicircular canal in the superior semicircular canal will make 90 degrees orientation. All right, now this we are seeing the round window where now the cochlea empties into the, or rather doesn't empty, but opens into the middle ear. And you can now see the basal turn of the cochlea there. Okay, so generally, that is the anatomy of the inner ear as seen under CT image. We can now talk about the middle ear. It's also called the tympanic cavity. The middle ear cavity or the tympanic cavity is an irregular space within the petrous bone. The main function of the middle ear is to house the ear ossicles, the ossicular chain. Let's talk about the ossicular chain. So there are three ear ossicles. We have the malleus, we have the incus and stapes. Very tiny bones that are joined by synovial joints actually. So this joint here is the joint between the incus and the malleus. It's called the anquido-malleolar joint. And this is the joint between incus and stapes called the anquidostapedio joint. Each of the ear ossicles have some parts. So like for the malleus, we have the head there, the neck, and this long process, the manubrium of the malleus. For the incus, we have the body of incus, then short process and long process. The long process ends at the lenticular process there. And then for stapes, the major thing is the head and the two crura, the posterior crus and the anterior crus, which meet at the foot plate. So this foot plate is the one that attaches to the oval window of the vestibule. This manubrium of the malleus is what attaches to the eardrum laterally. From an embryological point of view, the malleus and incus are from the first pharyngeal arc, but the stapes is from the second pharyngeal arc. The main aim of the ossicular chain is to transmit vibrations from the middle ear, from the eardrum to the inner ear. But as they transmit vibrations, there'll be amplification. The orientation, the morphology of the ossicular chain, the way they're organized, is a protective mechanism of its own. So that if there's some strong forces, the ossicular chain is not disrupted. From what you can see, there'll be more of collapsible rather than being disrupted. There's some protective mechanisms that the middle ear has against trauma or against excessive sound. And one of them is the morphological orientation of the ossicular chain. It's able to collapse instead of the bones getting the joints getting disrupted in case you have some high excursions of vibrations. But there are other mechanisms as well. So apart from the organization or the orientation of the ossicular chain, you also have the presence of the eustachian tube, which connects the middle ear cavity to the pharynx. So again, balances pressure between middle ear and the outer ear. And the other protective mechanism is the muscles. There's some muscles which attach to malleus, another one's touching to stapes. They contract, and the contraction of these muscles seems to be reflexes based on the amplitude of vibrations which are present in the ear. So they also protect. Okay, so from the outer ear, vibrations will be developed from the eardrum, then this vibration picked by the malleus, then goes to the anquidomalleolar joint, to the incus, then the anquidostapedio joint to the stapes, and then from stapes to the oval window. Then from the oval window, because we're now in the vestibule. We divide the middle ear cavity into three regions. So there are three spaces which are continuous. We have what we call the mesotympanum, This is the mesotympanum. The mesotympanum is actually the middle ear cavity proper. So you can call the tympanic cavity proper. This is the region that corresponds to the level of the eardrum. Then you have the epitympanum, this region here, the region above the level of the superior margin of the eardrum. And then we have the hypotympanum. This is the region below the level of the inferior margin of the eardrum. So we have the epitympanum, the mesotympanum, and the hypotympanum. Let's begin with the epitympanum. The epitympanum, which is this one, is also called the epitympanic recess or the attic. It is the most superior part of the tympanic cavity above the level of the tip of the scutum. This is the scutum. The scutum is that sharp inferior margin of the upper bone or the upper attachment of the eardrum. This point here is what we call the scutum. So the superior rim of attachment of the eardrum has a sharp projection inferiorly, which we call the scutum. If you take a horizontal from the level of the scutum, horizontally perhaps to the tympanic portion of the facial nerve, which is that one, the region above that imaginary line is what we call the epitympanum. The epitympanum therefore houses the following. We can have the head of malleus inside there. We do have the inguinalmalleolar joint, and we have the body and short process of the incus there. Remember, it's just the body and short process of the incus. Now look, if you have to take a horizontal plane through this region, what would you see? You'll see something that looks like ice cream cone. I'll show you that shortly. But this is a coronal section, not axial, but coronal section through the middle ear. So we see this is the middle ear cavity. This is the epitympanum. This is the tympanic cavity proper, and this is the hypotympanum. So we expect the eardrum to be somewhere there, corresponding to that blue line there. This is the scutum, or this one, that's the scutum. So if you take a horizontal from here to there, the tympanic portion of the facial nerve, this structure above, this region above is the epitympanum. I've told you that the normal appearance of the malleus and incus on axial CT gives the rise to that thing that will look like ice cream cone. Let me show you that from this video as well. So we want to cut this as we see different planes. The cut is from above. It's now the video is playing. We are moving down. So this is the level of the mastoid air cells you can see. And we are starting to see the epitympanum there. This is the otic capsule, remember. So the superior semicircular canals, the anterior limb and the posterior limb there. We are now at the level of the epitympanum still, and we are starting to see the ossicular chain there. So this is the epitympanum. This is the additus adamantrum, and this is the mastoid antrum. These are mastoid air cells. Now the typical ice cream cone is being noted there, but we also note the vestibule there. We can also see the lateral semicircular canal there. We can see the labyrinthine portion of the facial nerve there, geniculate ganglion, and the tympanic portion of the facial nerve there. This is the internal auditory meatus. So this is not quite at the same horizontal level as this one. This is still slightly above. So epitympanum and the adductors, we are starting to see that. We are not yet at this level on this side. All right. So you've seen the typical ice cream cone there. Maybe this one will show us something much better. It's a magnified image of what we just seen. So this is the otic capsule with the anterior and posterior limb of the superior semicircular canal. We're starting to see the adductus addantrum there. This is the masseodentum, and this is now the malleus and the incus there within the epitympanum. You can see the facial nerve there entering the labyrinthine part, the genu, and the tympanic part there. Now that typical ice cream cone is coming up. Is the vestibule, the lateral semicircular canal there. You may have some anterior recess of the epitympanum. So the anterior recess of the epitympanum is simply called the anterior epitympanic recess, which is this one. And occasionally there's a bony ridge that separates the actual epitympanum with that anterior recess. And that bony ridge is what we call the cog, as you can see there. All right, so that's the ice cream cone appearance with the malleus and body and short process of incus. Sorry, I'll take you back to that video to show you that Prusak. You need to understand what it is shortly. All right, there. So you can see the Prusak space. The Prusak space is this space between the superior margin of the attachment of the eardrum, this bright thing, which in coronal section will appear as the scutum. And now the manubrium, or rather the side of the malleus. So this space here, that space there is what we call the Prusak space. You can see the lateral semicircular canal now nicely. All right, so we are still slicing downwards. It will move shortly. Okay, now we're down. Now you can see the incudomalleolar joint there. Right, so that is the epitympanum. Finally, you can still see that. Usually, the incus has a small depression on its posterior end, which we call the incudal fossa. This will make part of the posterior wall of the middle ear. Now, importantly, remember that the epitympanum continues posteriorly with the masseodentum via the adductus addantrum. I'd already shown you that one. We can now talk about the mesotympanum. The mesotympanum is this region here. Let me put that. So this is the mesotympanum. It is the tympanic cavity proper. It constitutes the main compartment of the tympanic cavity. Nothing much to say. The rest of the components of the ossicular chain rest within the middle ear proper. So this middle ear proper is surrounded by laterally the tympanic membrane, which is this one. Superiorly, the epitympanum, which is this one. Medially, the lateral wall of the inner ear, which is this one. And we'll be talking about the components on that lateral wall of the middle ear. We have the oval window, round window, and the promontory of the cochlea. Inferiorly, we have the hypotympanum, which is this region here. Posteriorly, we have the retrotympanum, which has some structures constituting the posterior wall of the middle ear. We'll talk about them. And anteriorly, we have the protympanum, basically forming the anterior wall of the middle ear cavity. Again, we'll talk about it. Lastly, we have the hypotympanum, which is the portion of the middle ear cavity inferior to the lower margin of the attachment of the tympanic membrane. It's just a shallow depression in the floor of the middle ear, nothing much about it, but important is that this is the side that gives rise to the auditory tube. So auditory tube connects to the hypotympanum to the nasopharynx. Having said so, we can now talk about boundaries and relation anatomy of the middle ear. We can view the middle ear as a 3D structure. It's a 3-dimensional structure. So it will have a roof, it will have a floor, and it will have 4 walls: anterior wall, posterior wall, medial wall, and lateral wall. Let's begin with the roof. The roof, which is the upper part, is this thin bone, which we call tegmen tympani. That very thin bone, tegmen tympani. This tegmen tympani separates the middle ear from the cranial cavity, and in particular, the middle cranial fossa. Then the floor is this part here. These are coronal section through the middle ear. So this is the roof, this is the floor. The floor, the inferior wall, is very thin bone that separates the middle ear, and in particular the hypotympanum, from the jugular bulb. Sometimes this bone could be deficient, and so there's a thin membrane separating the internal jugular vein with the middle ear. Now the lateral wall is this part here. This is the tympanic membrane. Apart from the tympanic membrane, the bony attachment of the tympanic membrane also constitutes the lateral wall. And as you can see, the tympanic membrane separates the middle ear from the outer ear. Now, the margin, the superior margin, there is what we call the scrotum, if you remember that part. Usually, there's a nerve very close to the tympanic membrane that's called the coda tympani, which is a branch of facial nerve. It almost also lies close to the lateral wall. This image captures that. So this is the tympanic membrane. This is the malleus attaching to the tympanic membrane there. And then this is the rim of the tympanic membrane there. That's coda tympani, a branch of the mastoid part of the facial nerve, passing through and very close to the middle ear, very close to the tympanic membrane as it goes anteriorly. Okay, let's say something more about the tympanic membrane, although it's not osseous. So it's a membrane, as the name suggests, highly folded. When you look at it end face, we'll have this outer margin, the annular ligament, almost fibrocartilaginous rim around the membrane. It is the fibrocartilaginous rim of attachment to the bony rim. The upper part of the membrane is a bit lax, and it's called the pars flaccida. The rest of the membrane is quite tight, and it's called the pars tensa. The region of attachment of the malleus is there. Towards the apex of the region of attachment there, the tympanic membrane has the highest curvature there. And the point of highest curvature of the tympanic membrane is what we call the umbo. So the point of highest curvature of the tympanic membrane. The tympanic membrane is not quite vertical, it's slightly oblique. The anterior and the floor part go slightly medial, and so it's not angulated, it's not vertical, so to speak. It's a bit obliquely placed, and that's why we're having that orientation there. Okay, now we can talk about the medial wall. The medial wall of the tympanic cavity separates the tympanic cavity from the inner ear. And it has the following. So we have the promontory, which is the prominence created by the basal turn of the cochlea. We have the oval window, which is the point of attachment of the foot process, of the foot plate of the steps. And the round window, which is the one that dampens the vibration from the cochlea. So usually here, there's also a membrane that covers it. The membrane that covers that place is called the secondary tympanic membrane. Don't confuse it with the actual tympanic membrane, which you may want to call the primary tympanic membrane then. We also have the facial prominence. The facial prominence is the impression of the tympanic part of the facial nerve, the horizontal part of the facial nerve. Remember, the horizontal part of the facial nerve does not give any branch, but just crosses like that. So those are the structures in the medial wall of the tympanic cavity. We can now talk about the posterior wall, which is partly this region here. The posterior wall of the tympanic cavity is separated from the mastod air cells, and also to some extent the posterior cranial fossa. That's the following. We have the prominence of the lateral semicircular canal, which is that one on the upper part. We have the pyramidal eminence. The pyramidal eminence is the one that contains the stapedius muscle, which is this one here. There's a nerve that will supply it, which will be coming from facial nerve, and now you can see facial nerve very close to that point. We have the adductus addentrum, which is the irregular aperture from the epitympanum towards the mastod antrum. We had already seen it in the images. And we have the fossa of the incus, which is basically also what I'd shown you earlier, but perhaps I can show you that one again on these images. So we are focusing on this image to appreciate the anatomy of the posterior wall of the middle ear. We can see the mastod air cells here, and much posteriorly, we can see the posterior cranial fossa there. That is the adductus addentrum. Let me take it back a bit. So this is the mastod antrum and the adductus addentrum. So those ones projecting posteriorly. You can see the prominence of the lateral semicircular canal there. We can also see the fossa of the incus there, posterior. And we are about to see the pyramid. Okay, that's the pyramidal eminence, which is also posterior. So those are the structures which are on the posterior wall of the middle ear. How about the anterior wall? The anterior wall has openings, but also has very thin bone. The thin bone is more of anteroinferior, and that thin bone separated from the internal carotid artery, which runs within the carotid canal. Well, the bone is not as thin as if you compare with the one separating from the internal jugular vein or from the middle cranial fossa, but still thin. Much superiorly, that's where we have the opening. So the opening of the eustachian tube, also known as pharyngotympanic tube, that balances pressure between the middle ear and the outer ear. And the opening for the tensor tympani muscle, which, as the name suggests, creates some tension on the tympanic membrane through the malleus. Okay, so we'll use this image to learn the structures in the anterior wall of the middle ear cavity. In particular, we just want to see the openings. So we're starting to see that's the tensor tympani muscle and it's opening there. This is still the middle ear. Now we can see that's the auditory canal of the pharyngotympanic tube. Now going much down, we can see now this is the carotid canal, which is still also anterior. And this is the vertical part of the internal carotid artery, actually. So those are the anterior structures. Okay, so that summarizes the story of the middle ear. We can now talk about the external auditory canal. The external auditory canal is part of the outer ear. It's an S-shaped tunnel that extends from the concha of the ear to the tympanic membrane. Now, perhaps you don't know what concha is. Maybe you can take this opportunity to learn the parts of the pinna of the ear. So this is the concha, and that's the opening of the external auditory meatus. We can take this opportunity to learn the others. So this is the tragus, and this is the antitragus. The space between them is called the intertragic notch or the intertragal notch. The inferior to that is that soft part which doesn't have cartilage, it's called the lobule. Extending from that, this outer circumference is called the helix, and the one that follows is called the antihelix. The space between the two is called the scapha. The scapha is broad anteriorly and superiorly in that region, which we call the fossa triangularis, so the triangular fossa. The helix may have something like a tubercle there, which we call the Darwin's tubercle. So anyway, we are saying that the external auditory meatus starts from the margin of this concha there. Going inwards, measures about 25 to 30 millimeters long. This is the concha, and so this is the external auditory meatus, extending all the way from there to the eardrum. The floor and the anterior wall of the internal auditory meatus are quite long because of what I've just told you, that the eardrum is not vertical, it's angulated. So the inferior margin of the eardrum is more medial than the superior margin, and the anterior margin more medial than the posterior margin. It lies obliquely. The external auditory canal has two portions. The outer portion is cartilaginous, and the inner portion is bony. So the outer cartilaginous part takes a third, and the inner zone takes 2/3. The outer part will be appearing slightly wider than the inner zone, as we can see from this image. All right, okay, this is not a video, but it's still showing us the external auditory meatus. So first note that it's not straight, that it is curved. As we can see, that's the curvature. So entering through that one goes posteriorly that way. So that's the external auditory meatus. Note this is the temporomandibular joint, and this is the mastoid air cells. I want us to particularly talk about the bony part of the external auditory meatus. It's narrower than the cartilaginous portion. The bony part is in particular directed more anteriorly and inferiorly. Now, this one shows us that anatomy also. So this is a coronal section, and it appreciates the fact that it goes slightly inferiorly from that region. The posterior superior wall of the bony part of the external auditory canal is formed by the squamous portion of the temporal bone. So just the posterior superior wall only. The rest, which means the inferior part of the posterior wall, then the floor, and the anterior wall, those ones are formed by the tympanic plate, the tympanic portion of the temporal bone. In terms of its relational anatomy, the condylar process of the mandible will be anterior to the external auditory canal, and the mastoid air cells will be posterior to the external auditory canal. Look at that here. So this is the external auditory canal. Let's start that again. It's running so fast. So this is the external auditory meatus or canals. This is the condylar process of the mandible. So this is the temporomandibular joints, and this is the mastoid air cells. So mastoid air cells are posterior, and temporomandibular joint is anterior. Those are important relation anatomy for the external auditory meatus. You can also appreciate the curvature of the external auditory meatus there. Great, so that basically summarizes the anatomy that I wanted us to talk about. But as I told you, I'll show you some images of axial CT scan of the temporal bone for you to be able to appreciate the anatomy. So I'll play the first one, and you'll see the various components slowly. Then I'll give you time to try to name as much as possible on the second image. Okay, so I'm playing the first image now. From above going down, we can see a number of structures there. The anterior limb of the superior semicircular canal and the posterior limb. So this is the otic capsule. On this other side, we can see the antrum of the mastoid. So that's the mastoid antrum. We can also see the mastoid air cells there. So that's the otic capsule. Remember, it's very dense bone, very thick bone, very protective to the components of the inner ear. Still playing down, so this is the epitympanum. You can see it there. It's also called the attic, the uppermost part of the middle ear cavity. And remember, it connects to the mastoid antrum through the apparatus adantrum. You can see the posterior semicircular canal. Its orientation is almost parallel or in long axis the petrous bone. You can also see the apparatus antrum there. You can see the groove of the sigmoid medial to the mastoid component there. Remember, sigmoid sinus, the one that will extend down to become the internal jugular vein, and that the internal jugular vein is the one that grooves the lower part. Here we are seeing facial nerve entering through the internal auditory meatus. So this one here is the internal auditory meatus. The labyrinthine part of the facial nerve will pass through there. Remember, it will turn at some point at the genu, and that green line shows you the outline of the facial nerve. Then it becomes the tympanic part of the facial nerve lying on the medial wall of the tympanic cavity. Vestibulocochlear nerve is also a content of the internal auditory meatus. Remember that. This is a slightly lower level, and we are seeing the ice cream cone appearance in the epitympanum, head of malleus, and the body of incus there. We can also see some segments of facial nerve. Importantly, we've also seen the vestibule there. So that's the vestibule. Remember, the vestibule is the largest part of the otic capsule. The vestibular ducts are a small extension from the vestibule, emptying up to the posterior cranial fossa. This shows you the tympanic segment of the facial nerve, which is also called the horizontal segment of the facial nerve. Remember, it doesn't give you any branches. From previous lecture, we learned that. Okay, still following. Now we can see the basal turn of the cochlea. And so this basal turn of the cochlea is the one that usually gives you that big impression there, the promontory of the cochlea, which is on the medial wall of the middle ear. This is vestibule, and next to it, we'll be seeing the oval, sorry, the round window. We are a bit lower now. So that's the oval window at that point. Now, this is the cochlea itself. You can see the cochlea. We are seeing the intermediate turn and the apical turn of the cochlea at that point. We are still scanning through. And now we are seeing facial nerve within the masted component, masted segment of the facial nerve there. This is the one that's going to open through the stellomasted foramen. Okay, here we are seeing the external auditory canal. We expect the tympanic membrane to be somewhere there. Now that is the external auditory canal, well presented. We're much lower down, so this is now the temporomandibular joint. And here we see the impression of the jugular fossa. Remember, I told you that this bone can sometimes be very thin. And so jugular vein making almost contact with the middle ear. So that is from my part, but I want to give you something on your part. Now, what you're going to do is this with this particular video that I'm going to play. I'll play it slowly. There's some structures which have been numbered from number 1 onwards. Try to name as many structures as possible from that particular video. Just for your revision, at least you should know number 3 and number 4 right now. Even number 5 should be obvious. Number 6 should be obvious. Number 9 should be obvious to you. Even number 11, even number 10 should be obvious actually. $20 should be very obvious. Even those ones, you should be able to tell what they are. There, try as much as possible to name as many things as possible there. We are still playing it. I've talked much about 39 and 41. I've also talked much about 44 there. We've said much about that region as well. Even that part. And of course, those ones. I hope you realize that now we are much higher. So the cut was from below upwards. All right, so that is it. That was just for your revision. So that marks the end of this lecture on part 1 of the anatomy of the ear, where we focused on temporal bone anatomy. The second part of the lecture of the ear focuses on the auditory and vestibular apparatus, and I've already developed that one. The link to the lecture is there, focusing on the auditory and vestibular apparatus. The lecture will look like that in the front page of it. So I suggest that for you to have complete understanding of ear anatomy, you need to listen to both the first and this second part of the lecture. Thank you very much. So we will stop there. The next lecture series that we're going to have on topographic anatomy of the head and neck will now be going much down to the neck region, focusing on the neck triangles. And in particular, we'll be looking at the posterior neck triangles. All right, have a nice time.